Hey, welcome back to software engineering. Today we get into, you thought it was going to be implementation, but it's not, it's testing. Haha, got you. Yeah, you get to start testing. Now, Somerville uses the traditional approach to testing where we write software and then we test it. But I decided that in this class, this time around, we're going to do a little test-driven development because that's become very popular over the last few years. And I know a lot of companies around here are at least claiming that they're moving in that direction. So, you know, better to learn it than not. So I think everybody probably intuitively understands the traditional approach to testing, which is the one that's mostly described here. You write some code, you test it. We'll go into a little bit more detail about how that works. But test-driven development is the other way around. We write tests, then we write code to fit those tests. All right. And so test-driven development is basically a very simple ethos, but it's in practice really hard to do, or at least for many people. It's something that's hard to get the hang of. So we write the tests that we want the code to pass. Then we write the code until it passes those tests, and then we stop. And if we want to add more features, then we have to add more tests. And so our whole development process is basically just writing tests and then passing them. So it makes it into more of a challenge. The art of writing a test, though, is something that is hard to acquire, especially before you have the code. And the art of writing good tests is something that takes a very long time to master. So you can get a little bit of practice in this session. That's what we're going to do. We're going to write the tests first, and then you or another team will write the majority of the code. So this is a little bit less traditional. Generally speaking, if you're doing test-driven development, it's going to be the same team writing the tests as the code. Whereas in the more conventional approach, that we're going to talk about here soon, you might have different teams that write the code and then different teams that are responsible for the testing and quality assurance. And before we move on, I want to say sorry for Canvas going down during the exam. That is a real bummer. Let me know if you feel like you didn't get the score that you deserved. I want everybody to feel like they got what they earned before it went down. But since it went down for everybody at the same time, I think it's fair to just give everybody what they got and then curve it. If you haven't already, vote in the poll just above today's video in Discord on how happy you feel about the score. And again, let me know if you feel like there was a question that maybe Canvas erased on you or something that you didn't get credit for. Look over your exam. Make sure you got credit for everything that you completed before it decided to poop out on us. And, in the future, don't freak out. You could have bought yourself an extra, 10 minutes of work because it pooped out with about 15 minutes left. So if you just kept chugging through and didn't freak out, you could have had an extra 15 minutes, depending on how long you spent freaking out. All right, so on to test-driven, or software testing, actually, not test-driven development, because Somerville didn't have that yet. These slides are pretty old. Test-driven development is older than these slides are. It probably starts getting popular in earnest in the early 2000s, but it really didn't take off till the last 5, maybe 10 years. And now you see a lot more, at least hype on it. It's still the minority of development houses, but it's something to consider. All right, so first, what do we do? Why do we test? Why do we test at all? Right? Why do we bother? Testing is intended to show that a program does what it's intended to do. This is the part that you're probably not familiar with. You've done your homeworks in your other classes, and then you verified that they do what they're intended. But they're so simple that what they're intended to do can be described in a single page. All the software you guys have needs many pages to be described. It needs the requirements document, and then most of those are incomplete to boot. So you need a very large amount of description to verify the software does everything it's supposed to do. But that second part is really familiar with this, to discover the defects. We're all pretty well acquainted with what that means. When you test software, you execute a program using artificial data. This might be a little bit unusual to some of you. It also makes it really difficult to test something like a user interface, right? So when we're testing a program, if it's a user interface program, artificial data might mean just random clicking. It might mean random key presses. It's really hard to make artificial data for a user interface. So There's a little cottage industry of different products that are available for that. You don't have to use those. Your artificial data for user interfaces doesn't have to be serious because none of you have a very serious user interface. But for everything else, let's say you're testing a piece of your code that handles the networking. You would try to send it something, a test, and then you would try to see if you can maybe receive that same test. So you're not giving it real data from your software. You're breaking it down into a module, and then you're feeding it test data. Check the results of the test for errors, anomalies, anything that indicates that your program is not running correctly. And we can reveal that errors are present by running tests, but we can't reveal that errors are absent because our test coverage is never complete. We've never tested every possible scenario that can occur, especially in a program that is large. It's impossible to do that. So we just try to test as much as we can. Testing is part of the more general verification and validation process, which includes other techniques that we're not really going to go over. So again, we're trying to demonstrate that the developer and customer have an agreement over the software meeting its requirements. The tests prove that the software meets its requirements. And then we also want to discover situations where the software is behaving incorrectly. So those would be bugs or conventional defects. Those aren't necessarily because it doesn't conform to specification. Those are because it doesn't do what it's intended to do. So that first goal, that's validation testing. We're trying to validate that the software performs correctly. So you should have, in your requirements document, been as objective as possible. You should have listed different non-functional requirements and how you might validate them. So take a look at the requirements document you've inherited and see how many of the requirements you can validate in code. It should be as many as possible, right? You should be able to validate. Let's say it says that the response time for a network operation is no longer than 100 milliseconds. Well, your code for testing should set a timer. If it gets to 100 milliseconds, it should output an error because it's longer than 100 milliseconds. That's an example of a simple test to validate a requirement. And then the second goal, obviously, defect testing. We should be pretty familiar with. In this case, we're trying to create test cases that we think will error out, test cases that we think might handle obscure edge cases, test cases that handle situations that the system isn't normally put in, but that the system needs to endure and not crash or handle elegantly or whatever. So if we're testing a user interface, for example, we want to test what happens if somebody piano keyboards, or if somebody clicks the mouse 1,000 times, or clicks left and right repeatedly. If we're testing math, anything that takes an integer as an argument, we want to test maxint. We want to test minint. Does your function still work if it gets the biggest possible integer, the smallest possible integer? How about 0? If we've got floats as input, we want to test float.infinity, float.not a number, etc. We want to test all the different weird edge cases that could come up and make sure that our software can handle them. Validation testing, again, we're trying to prove to ourselves and then to the customer that the system meets spec. The successful validation test shows that the system is operating as intended. Defect testing, we're trying to discover faults in the program, but a successful defect test doesn't necessarily mean that the software is free from defects. Well, it does mean that it's free from the defects that we've thought of, which is at least something. Check out our input-output figure. Somerville loves his figures. So input test data goes into your system. Output test results indicate defects. Back to the drawing board, fix the system. So again, just to break down the difference between validation and verification or defect testing. Verification is, are we building the project right? Are we building the product right? Is it functioning as a good piece of software should? And validation is, are we building the right product? Are we actually building what the user requires? Does the product do what the user wants it to do? So one is conformity to the spec and generally functioning properly. The other is conforming to the requirements and doing what the user actually needs it to do. V and V confidence. So we're trying to establish that the system is fit for purpose. Those two things together, validation and verification, you got both of those, then you have a software that is a good fit. Software that's full of defects but does exactly what it's supposed to do is useless. Software that's free of defects but does nothing it's supposed to do is equally useless. You get both of those, you have a useful piece of software. So depending on the system's purpose, user expectations, and marketing department, those things might carry varying levels of significance. The software's purpose depends on how critical the software is to an organization. User expectations might be lower for certain kinds of software. We all recognize that enterprise software, something like Bannerweb, is going to be filled to the brim with defects and timeouts and all this lovely stuff that randomly goes wrong. It doesn't make it less fit necessarily. It makes it more irritating to use, but we recognize that that kind of software, you don't want to pay the premium for making it perfect because it's just not worth it. So it's acceptable even though it's filled with bugs. The marketing environment, sometimes getting your product out might be more important than having it be free from defect. I mentioned this in the last phase too, that sometimes being first is much more important than being best. Being first is often the most important thing. So sometimes having your software fit the purpose you're designing it for is more important than having it be free of defects. We're going to skip over static and dynamic verification for now. Might not come back to it anyway. So inspections and testing, what do we got? The different parts of the environment here. We got our requirement specification, our architecture, and our design models. So we got up to here done basically. We've got our database schema for some of you for whom that is involved. We don't have a program written yet, but we started. We've got a skeleton. So now it's kind of time to build a prototype, or in the test-driven model, to build the tests first and then get the prototype. And that's going to feed into our final program. So let's talk about inspections a little bit, because we're not going to do inspections yet, seeing as we have no code, but it's something to think about as you go. So inspections will be people who are examining the code with the aim of discovering anomalies and defects. Inspections don't necessarily require you to execute the code, so an inspection is different from a test in the sense that you're just looking at it, you're not necessarily executing it. And you might inspect different parts of your system, so just something to consider as you go here. You might be inspecting the requirements and design document. I am certain that if you guys take a good hard look at the design document you inherited, you will find numerous inconsistencies, defects, and failures to validate already. So before you go gung-ho into typing out tests for the code skeleton and everything, be aware that most of what you have is probably wrong or suffers from some kind of issues, and it's going to need to be changed anyway. So a good inspection is better than having to write a bunch of tests to get there. Inspections are an effective technique for discovering program errors. During testing, errors can mask other errors. Inspection, on the other hand, a static process. You don't have to be concerned about interactions between errors. We'll skip over the rest of this text here. Inspections and testing are complementary, so you should be doing both. You should be inspecting the code, you should be inspecting your design, your requirements. You should also be writing tests. Those are not independent of each other. You can't get away with not writing any tests because your organization looks at everything very carefully, and likewise you can't get away with not looking anything carefully because your organization writes very robust tests. You must do both if you expect to write good software. Okay, so let's look at where we are in the software testing process, I guess. And again, this is a little different since we're in test-driven development, but we're starting here. We're starting at the design test cases phase, and that's what you're going to do today. You're going to write some test cases, and then at the same time, you're also going to prepare test data for some of those functions. It's going to be a long time before we get to running the program, though, because we have yet to write any of the code. All of our tests will fail at this point. So we can consider that we're in the development phase right now, more or less, although really we're before it because we're test-driven. So in the development phase, the system is tested, obviously during development, for bugs and defects. But then when the system is released, usually the development team is no longer attached to it, or at least not the entire staff of the development team. They're on to developing another product. And so in the release phase, the product is given to a separate testing team to test the complete version. Sometimes before it's released to users, there is a separate team that performs testing after the development team does. This is the mark of a large and successful organization, generally speaking. And sometimes this is just the maintenance team. It basically handles the fixing of the code after it's been released. Usually a few people carry over so that some of the wisdom is maintained. But again, these might be different people, and you can expect this to happen in this class as well, time permitting. We're going to transition to a release testing team after we're done with implementation too. And then there's user testing, the worst kind, right? Where the users get to test the system and find out all the bugs. This is the modern software developer's favorite test because they don't have to do anything. So development testing includes unit testing, which is what we're focusing on in the beginning here, and then component and system testing, which is mainly integration testing, which we'll talk about later. So development testing includes unit testing, which is testing individual program units or object classes. So unit testing means that you're testing possibly even individual lines, but generally speaking, the smallest unit that's tested is a single method. So we're going to be writing unit tests for all of the methods in our code. And then we also generally want to unit test entire objects. So we want to unit test classes in the Java paradigm that we're familiar with. And I'll show you how you might do those in a second here, and then we'll skip component and system testing and go back to those later. So unit testing is testing individual components in isolation. So we're not testing the whole program, we're only testing that one class. For those of you that inherited a design document where you have a single very large class that handles pretty much the whole program, this is probably the time when you're going to have to split that up. Otherwise your unit test is going to be a bit of a mess. Unit testing is generally to catch defects, but we can do a little bit of validation here as well. And units are individual functions or methods within an object, right? So as I mentioned earlier, the smallest unit that we usually test is an individual method. Then we'll generally test the entire class with all of its methods and its normal functionality being tested. And sometimes we might test composite components, maybe interfaces or different things within the class, but we're not going to worry about that too much here. Object class testing. Complete test coverage of a class involves testing all the operations associated with the object, setting and interrogating all the object's attributes, that means all of its fields in our Java parlance again, and then exercising the object in all of its possible states. Why do we do object-oriented programming, right? What's the main reason we do it? To easily represent the state of our program as the state of different objects communicating with one another with messages. That's a really, really big simplification, but that's why we do object-oriented programming in the first place. And a lot of this agile software engineering stuff is very focused on object-oriented programs and how to test them. So if you have an object in the traditional object-oriented way, that object has state. Sometimes that state is just represented by its fields. Sometimes you have a more explicit state management system, but the goal of unit testing is to make sure that that object is functioning properly in all of its different states. Inheritance makes that process a lot more difficult, as the information to be tested is not localized. We'll see how that works. And most of you don't have too much inheritance. So let's say we have a weather station class. Again, a unit test tests a single class or object, or maybe the methods that it has as well. So we've got our one weather station object. It's got one field, the identifier, and it's got a series of methods. We need to develop test cases for, let's say, report weather, calibrate, test, startup, and shutdown. So we're going to test those methods individually. And then we want to test that the state model for it works correctly as well. So we want to identify the different sequences of state transitions that the weather station should have and make sure that the events sequence correctly, that the states transition correctly, and make sure that all the fields and everything of the object are as intended during each state and during the transitions, perhaps if necessary too. So what are the states that the weather station might be in? Well, it might be in its shutdown state, then it gets set to running, and then it shuts down again. It might be configuring, then running, then testing, then transmitting, then running. I mean, it depends, obviously, on the nature of the object. Whenever possible, we want to make these unit tests automated, and that's what we're going to do here today as well. We're going to try to make automated unit tests that run and get checked without manual intervention. We would make use of a automated testing framework like JUnit if we had time, but not all of you are writing your programs in Java, so I'm not going to focus on JUnit as such. Instead, we're just going to write all of our tests in the main method, which is a little bit janky but works well for our purposes here. But realize that if you were writing real unit tests, you would use a automated testing framework like JUnit, and you're welcome to use JUnit if you're writing your application in Eclipse. It should ship with all of your copies of Eclipse here. Unit testing frameworks provide generic test classes that you can extend to create specific test cases. They basically let you go through multiple testing suites. They have a nice GUI, show you what happens when tests fail, all this good stuff. But again, it's a little overkill for what we're doing. So there's a setup part where you initialize your system with the test cases, and if you're testing an entire class, you gotta instantiate the object properly, all of that good stuff. Or maybe instantiate the object improperly and verify that it fails elegantly, but either way, you need to do some instantiation first. You might have to simulate the outer boundaries of that class with some other outside data. And then there's a call part where you're going to be calling the object or the method to test it. And then there's the assertion, where you compare that the result of the call meets the expected result. That's what we're going to rely on, mostly in order to build our unit tests here as we go. Test cases should show that when used as expected, the component does what you intended to do, and when used as unexpected, it fails elegantly, or continues chugging along, or crashes if that's what it's supposed to do. It's up to you. If there are defects in the component, then those should be revealed by the test cases. So we got two types of unit tests: to reflect normal operation of the program, verify that it works as intended, and then to be testing edge cases or unexpected inputs or unexpected operation, and make sure that everything's properly processed and doesn't crash. So again, fails elegantly is usually the goal here. All right, that's enough for today about testing. I'm going to show you briefly what a unit test might look like in Eclipse. So I've got my testing sample built here. Let's say I'm testing a class called FileLogger. This class is supposed to save files, saves files to the log file on the user's system. Notice what I'm writing at the top of every complex field, method, and constructor is one of these JavaDocs style comments, the /**. When you hover over things that have been JavaDoc'd, you will get a tooltip that reads the comment out for you. This is very useful. These are also automatically generated to serve as your code's documentation, also very helpful. So all of these JavaDocs should describe what all the different methods and fields are supposed to do. Eventually, by the end of the testing phase, you will have to document your entire program, so you may as well get started on it now. And as you write this documentation, it will help you to discover what you need to text. Certain things are automatically filled in, like the author slot and return and things like that for different methods. All right, so I have two fields here, a log, that's the file where logging is saved, and then a log ID, which is supposed to be semi-unique. And I have the constructor for FileLogger, which has no code except this statement, which you've probably never seen before. It's an assertion. An assertion is basically a footgun. It's a statement that says, if the contents inside are true, we can keep going. If not, just crash right here and return the line that it crashed on. So this allows you to write very simple tests, and the assertion will verify whether that test passed or not. So the contents of the assertion are essentially the test. Now, to enable assertions in Eclipse, you have to go through a step. After you've run your program at least once, you have to right-click on it, and you have to go to Run As, and go to Run Configurations, and then go to Arguments, and make sure the -EA argument has been added here. So -EA has to be added to your VM arguments. That allows assertions to run. When your program is built, so when it's actually compiled such that the user can execute it, not in the IDE, I mean, so when it's outside Eclipse, the asserts will do nothing. So that's why they're important here rather than if statements. So asserts get ignored for final compilation. They're used only in the IDE, basically, during the debugging process. So you can have as many asserts as you want, and it will never affect the production version of your product. It will only affect the development version. So The log ID is supposed to be semi-unique, so I've asserted that it's not 0. That makes sense. I might want to assert that it's not a negative number. It shouldn't be a negative number, so assert that it's greater than 0. So both of these should pass in the constructor. I've got a method called readAllIDs, which is supposed to return all of the IDs written to the file in an integer array. And then I've written my primary unit test, which, again, since we don't want to deal with JUnit or anything fancy, I've just written this as a main method on the object. So every object, every class you have will have a main method like this, where you'll run through your test suite. You might want to group the individual tests into their own methods too, but that's up to you. So I've created a new file logger. I'm asserting that the log file exists. It's something that should be instantiated in the constructor, right? It should build the file. If the file doesn't exist, there's a problem. Logging won't happen. We should crash. So that's one simple test. Then I'm going to get all of the integer IDs, and I'm going to write an assertion later. I haven't done it yet that checks that there's no duplicates. So that's an example of beginning the test. And there would probably be a lot more other stuff to do here, but I think that should give you the general idea. And if you have any questions, I'll answer them in Discord. So all right, get to it. Don't forget that you're going to have to keep maintaining your design and requirements document as you go. If the design you get turns out to be a huge and you can't use it at all, then I guess you're just going to have to update it completely, right? But you should try to stick to the previous team's design at first. Make sure that there's is complete garbage before you abandon it. Maybe there's something redeemable there, so try to use theirs. Abandon only as necessary. Okay, see you in Discord.